right, we are on to section 9.1.3, and now we're going to look at some properties of polynomials. And so this is what you should know so far about polynomial functions. If we look at this equation, f of x equals x minus 6 x times x minus 6 quantity squared, that's going to have two real roots, and those roots would be at 0, because I would set x equal to 0. And then x minus 6 equal to 0 would give me 6. X equals 0 is a single root because it's raised to the first power. And that means that the graph crosses the x-axis. X equals 6 is what we call a double root because of the 2 here, 2 into the exponent. And that double root means that the graph bounces off the x-axis. We also talked about multiplicity. Again, that's kind of going with the crossing or bouncing. So multiplicity describes how many times a root is a solution to the equation. Remember, odd multiplicities means the graph crosses the x-axis, where even multiplicities mean the graph bounces off the x-axis. Don't forget about that the cubic shuffles, though, with the odds. Remember, if it's raised to the first, it's going to go straight through. But if it's raised to like the third or fifth or seventh, it's going to flatten out and do like the cubic and then cross through. All right, then we had some vocabulary. So the roots or zeros of a polynomial, the x-intercepts of the graph of a polynomial, and the solution of a polynomial equation are all the same thing. So all those can be used interchangeably. Roots, zeros, x-intercepts, solutions. They would all be the same answers. All right, so we have some examples that I'd like you to try. So state the root of the function, the multiplicities, and if the graph passes through the x-axis or if it bounces off the x-axis at those places. So again, I can do the first one for you. The roots, if I said this one, that would be x equal to 0, so 0 would be a root. And then if I said x plus 3 equal to 0, that would give me x equals negative 3 as another root. So the multiplicity then for 0 would be, for x equals 0, that would be a multiplicity 1. And for x equals negative 3, that would be a multiplicity of 2. And again, multiplicity is just another name for the exponent. So we have 1 and 2. And then will it bounce or cross? So for x equals 0, it will cross. And for x equals negative 3, it's going to bounce. Again, even exponents bounce, or even multiplicities bounce, odd multiplicities cross. So go ahead and do these other two, try them out. So we should get x equals negative 5 and x equals 1. This 2 is not going to be a root, that's just like a leading coefficient. All right, so for the negative 5, our multiplicity would be 1, and for x equals 1, our multiplicity is 2. And so therefore, x equals negative 5 would cross, and x equals 1 would bounce. For the second one, again, this 4 is just a leading coefficient, so it's not actually going to be a root. Our roots would be 6 and negative 3. The multiplicity on the 6 is a 2, because that's your exponent, and the multiplicity on the negative 3 is a 3, again, because that's your exponent. At x equals 6, it would bounce because it has an even multiplicity. And at x equals -3, it would cross, doing the cubic shuffle because it's a 3, 5, 7. So we're going to put cross, cubic shuffle. And so here are some other things you can look at this for end behavior to help you remember. Again, I always said I like to think of it as like parabolas. So your degrees are going along the top here. Your leading coefficient sign is over here. So again, even degrees would be this column. So even degrees are always going to start and end in the same direction. Okay, think about parabolas. Even degrees are like parabolas. They either go like this or go like this. Okay. So this would be like an opening up parabola, and this would be an opening down parabola. And that's what it says right here, negative x squared, positive x squared. And again, the way we get it to be up, up is for the leading coefficient sign to be positive. And the way we get it to go down, down is for that leading coefficient sign to be negative. Odd degrees, I like to think of them as like a line. Y equals x to the first, so they're going to go like opposite directions. If your leading coefficient is positive, it's going to end positive. Remember, whatever way the leading coefficient is how it ends. So then it would start negative, and if our leading coefficient was negative, it's going to end negative, which would make it start positive. All right, from there we're going to look at trying to make pretty exact graphs. Let's try to make some exact graphs. So once it's in factored form. If we look at number 1, I'll do that with you guys. Remember, it's important to find the degree. And to find the degree, you'd have to remember, you'd have to think about multiplying this out. So I'd have x times x, which is x squared, times another x is x to the third. So the highest power of x would be 3, so that's our degree. Our leading term is positive 1, because there's a 1 in front here. Our end behavior then, so it's an odd degree with a positive leading coefficient. So it's going to end positive. Since it's an odd degree, like a line, it's going to have opposite start and ends. Our zeros then would be 4, 1, and -3. And the multiplicities on all these are 1s because the exponents are all 1s. Remember, to find our y-intercept then, we would have to plug 0 in for x. So if I plug 0 in for the x's, I'd have 0 minus 4 times 0 minus 1 times 0 plus 3. So I'd have -4 times -1 times 3, which would be 12. So 0, 12 would be my y-intercept. Now again, we won't be able to fit that on our graph. We're just kind of making sketches, but that would be our y-intercept. And so to make our graph then, we're going to plot all of our zeros. So plot a point at 4, at 1, and at -3. And I have to start with negative end behavior on the left. Remember, I'm crossing all of these x-axis. So I'm going to start down on the left, starting the negatives, cross through, cross through, cross through. Now again, our y-intercept should really be at 0, 12, but we can't go up that far. So our focus is mainly on getting the correct x-intercepts and whether it's bouncing or crossing those x-intercepts and the correct end behavior. That's our goal with this. All right, for the next one, we'll do one more together. Now I'm going to have a degree of 4 because I'd have, this will give me x squared times x is x to the third times x is x to the fourth. Our leading term would still be +1 because there's a +1 in front of that. And so our behavior on the right would be positive because it's the leading coefficient of positive. Our behavior on the right left then, it's an even, would have to be the same. So it's up, up. Our zeros would be 0, x equals 0, x equals -2, and x equals 3. And our multiplicity for the 0 is 1, multiplicity for the -2 is 2, and the multiplicity for the 3 is 1. If we're going to do the y-intercept again, I would set 0 in for the x's, and so that would give me 0 times 4 times -3. 0 plus 2 is 2, squared is 4. And then 0 times anything is 0, so my y-intercept will be 0, 0. So clearly we'll be able to make that point fit on our graph. All right, so here we go. We're going to plot our zeros. So I have one at 0, 0, -2, 0, and then 3, 0. Those are my zeros. My behavior has to start in the positive, and just be careful of your multiplicities now. So I have a multiplicity of 2 at the -2, so that means I'm going to bounce at the -2. So I'm going to come down, bounce off the -2, come back up. I'm going to have to cross at the 0, and then cross at the 3. So again, a couple things to quick check before your sketch. Make sure you have all the correct zeros, which I do. I have the correct end behavior, and I have the correct multiplicities. I am bouncing at the -2, crossing at the 0, crossing at the 3. All right, I'd like you to try this one. All right, so our degree here is going to be 3. Our leading term now is -2, so be careful. All right, so our degree is 3. Our leading term is negative, so that means we have to end negative, which means we would start positive. Our zeros are going to be x equals 1 and x equals -4. And our multiplicities are going to be 2 and 1. And when we do our intercept, we would be at y equals -2 times 0 minus 1 squared times 0 plus 4. So we'd be at -2, -1. 0 minus 1 is -1, -1 squared is 1 times 4. So it's -8. So 0, -8 would be our y-intercept. Again, we won't be able to fit that on a graph, so we just keep that in mind as we do our sketch. So, plot our points, x equals 1 and -4. It has to start in the positives, and it will end negative. And again, our bounce is going to occur right here at the 1. So I'm going to cross through the -4, bounce off at the 1, and then finish in my negatives. There's my sketch.